Have a great day, everyone. Today we solve the various problem and explain the process of the probability distributions, the cumulative distribution functions, the expected values of the random variables, the binomial distribution, and lastly, the Poisson distributions. Our question number is, from a box containing four red balls and two green balls, three balls are drawn in succession. Each ball being replaced in the box before the next draw is made. Find the probability distribution for the number of green balls. So our n here would be 3 that is being drawn in succession. So our given here is 3. And then we need to find the probability of the green balls, which is p equals to green. Then your green would be 2. So 2 over 6 equals to 1/3. 6 will be the total number of balls. And then after that, we need to substitute the value of your x, which is from 0 to 3, by your given formula. X equals to n, the combination of your n of x, p raised to x 1 minus p n minus 1. And then you substitute the value. Then from x equals to 0, so substitute the value here. So from 0 equals to, your n here would be 3. Then by combination of your x equals to 0, then multiply by your p, which is 1/3. Then raised to x would be 0. Then 1 minus p raised to 3 minus your x here would be, this is x, 0. Then after that, by manipulating all of this, you get 8 over 27. That will be your x equals to 0. And then we need to find also the p raised to x equals to 1. Then after that, substituting the value raised to 1, then 1 minus p raised to 3 minus 1, you get the value of p over x equals to 1, that is 4 over 9. And then after that, we need to get also the x equals to 2 by substituting the value from your formula. Then 1/3 equals to 2, then 1 minus p raised to 3 minus 2, you get the value of your x equals to 2, that is 2 over 9. Then after that, you need to get also the p over x equals to 3, because from a given, 3 balls are drawn in succession, so it is only 0 from your 3. 3 over c3, then multiply by 1/3 raised to 3, then 1 minus p raised to 3 minus 3. So you get the formula by x equals to 3, that is 1 over 27. And then from your problem, you need to find the probability distribution for the number of the green balls. So therefore, you need to make a table. The table. X p over x. So from 0, 1, 2, 3, the value of your 0 here would be 8 over 27, your 1 would be 4 over 9, your 2 would be 2 over 9, and lastly, you have 1 over 27. If you sum all of these values, you get 1. So that's the answers of the question number 1. Our problem number 2 is 3 cards drawn in succession from the deck without replacement. Then probability distribution for the number of spades. So our n here would be 3, and then the deck of the cards, the overall is 52, and then the number of spades and the deck of the cards is 13. So therefore, if you subtract the spade in the overall number of cards, it would be 39. So we need to get the value of your x equal to 0 up to 3, because there are only 3 cards that is being drawn in the succession. And then you substitute it into the value of your combinations, with if we have 13 out of 0, and then you have 39 cards out of 3 combinations, and then your overall 52 cards out of 3. So you have now your value of 41, 353, the value of your 0. And then you need to also get the number of your 1, the value of 1. So 13 out of 1, 39 out of 2, and then the overall 50 over c3, then 0.43588, and then p x equals to 0 equals to, so 13 is number of spades, so it's 2, x equals to 2, and then 39 out of 1 equals 52 over c3, so it will become 0.13765, and then p equals to x equals to 3 equals to 13 c3, 39 c0, 52 over C3. The overall, that would be 0.01294. And then find the probability distributions. If you make a table of it, so you have x over p over x, so 0, 1, 2, 3, 0.41353, 0.435888, 0.13765, 0.01294. The overall is equivalent to 1. Okay, that will be the value. The number 3 question is from a box containing 4 10 peso coin and 2 5 peso coins. 3 coins are selected at random without displacement. Determine the cumulative distribution function of the random variable representing the number 10 peso coins. And then you have your n here, which is 3, and the number of your 10 peso coins would be 4. The number of your 5 coins equals to 6, equals to 2, and the overall number of coins is equals to 6. Then the required is the p over t and the f over t, which is the representing the number of the 10 peso coins. Then the solutions. So you have your 5 peso here, and you have your 10 peso here, and then the total. So if I have 3 peso coins here, so therefore I have 0 10 peso. So it's equals to 15. And then if I have 2, I have 1 0. And then if I have 1 here, I have 2 10 peso here. It's 25. And if I have 0 5 peso, I have 3 peso here. Equals to 80. This, if you sum it up, so you get 3 3 3 3. Then after that, you need to find the probability distributions of the following, of 15, 20, 25, and 30. So P equals to T, your T here equals to 15. So equals to, if you substitute, so the value of your 10 peso coin is 4 over, the combination here would be 0, and then your 2 5 peso coin, and 3. So the 0 is your 4 would be your 10 peso coin, and then the value of the 10 peso coin in the 15 total would be 0, and your 2 peso coin, your 5 peso coin with the value would be 3. This is, so the overall would be 6, the total number of coins, over 3, the n. So if you sum it up, you have get the no probability, because this is a no value. And then after that, p t equals to 20. Then you have 4 here, then c1, because your 10 peso is 1 here, and then after that, your 2 5 peso coin, your 5 peso coin is c, then 2. So 6 over c3 is equivalent into 0.5. And then if your t equals to 25, so 4 c2, 2 c1, 6 c3 equivalent into 0.6. And then if you get the value of your t equals to 30, 4 over c3, then 2 c or 0. So from this value, and then substitute the value of your 6 total over 3, so the value of this is 0.5. Then for the cumulative distribution functions, because um, the the problem is about find the cumulative distribution functions, so you need to get the ft equals to, make a bracket of it, then 0, have no probability, 0.5, then you need to add the 0.5 by 0.6, and then sum it all, 0.5 plus 0.6 plus 0.5. So you get the value of your 0, 0.5, 1.1, and 1.6. So you that is how we're going to use this value. And then for the final touch, so you have your answer here between 0, 0.5, 1.1, and 1.6. So therefore, assumption here will be t, which is less than 0, for 15, which is from this. So 15, t would be greater than or equal to 15, then less than 225. Okay, so this is 0.5. And then for 1.5, 1.1, since 1.1, it is t equals to greater than or equal to 25 or less than 30. Then after that, for 1.6, we have for t that is greater than or equal to 30. So that is the final answer. I'm sorry, that is the final answer. Question number 4. An insurance company sets an annual premium on its life insurance policies that so that it makes an expected profit of 1% of the amount it would have to pay out of out upon death. Find the annual premium of that 200 peso life insurance policy for an individual who will die during this year with probability of 0.02. So you have a given here, which is the probability of that would be 0.02. The P of A would be the profits, and the required would be the X, or the annual premium. And then the solution is simply you multiply the 0.01, which is the 1%, by 200,000 peso, which is the annual premium life insurance, then equals to X, the with the unknowns, and then the deficit, or it is like the you need to subtract from um, the overall numbers, 1 minus the probability, which is 0.02. So it is like 1 1 minus P, or it is equivalent to Q. So 0.02, and then you add plus your X here, and then your 2,000, your 200,000 insurance, then multiply by 0.02 probability. And then when you um, calculate all of this, you have your formula number 50x plus 0.02x minus 4,000, and then you get by um, ship sold, you get the value of x equals to 6,000 peso. Okay, so that would be the answers, the annual premium of the 200 pesos life insurance policy for the individual that who will die during this year with the probability of 0.02. So this is the final answer. The question number 5. According to the study, there is roughly an 80% chance that a person of age 20 years, 65 years, suppose that three people of age 20 years are selected at random. Determine the probability distribution of the number alive at age 65. Also, find the probability of the number alive at age 65. Will be. So the given is we have 0.8, the k, or it's all the k, or it is equivalent also to into x, 0 1 2 3, and your n would be 3. And then you need to substitute into the formula that is being used in the number one question. So let us solve. So x equals to 0, p, probability that x equals to 0, it is, so the n is 3, then your x is 0, then the p, your p from the given is 0.8, and then raised to 0, and then 1 minus p with 0.8, then multiply raised to 3 minus 0, so you get the value of 0.08. And then p equals to x equals to 1, so you have your 3, c raised to 1, c equals to 1, which is 1 equals the number of x, and then 0.8 raised to 1, and then 1 minus 0.8, 3 minus 1. So the value is 0.096. Then p equals to x equals to 2. Then substitute 3, the combination of your c, 2, and then 0.8 raised to 2, then 1 minus 0.8 raised to 3 minus 2. So the answer is 0.384. So p, probability of x equals to 3. So substitute c3, 0.8 raised to 3, then 1 minus 0.8 raised to 3 minus 3. So your answer would be 0.512. And then the question is Letter A, exactly 2. So therefore, you get the probability that exactly 2, which is p equals to 2, the answer is 0.384. So therefore, the probability of x equals to 2 would be 0.384. That is already get from the solutions. So p at most 1. So at most 1, you need to solve for that. So x that is most 1. So therefore, it is less than or equal to 1. So your p, so therefore the x that is being less than or equal to 1, that is 0 and 1. So therefore p of x equals to 0, and you add the p over x equals to 1. So by substituting the given value, the x of 0 equals to 0.008 plus 0.096, the value of your 1. So you get the value of 0.104. And then c, at C, the question is at least 1. So therefore, at least 1, you need to get the value of your from 1 going to 3. So P, it would be x that is being more than or greater than or equal to 1. So therefore, P, x equals to 1 plus P, x equals to 2 plus 3, x equals to 3. And then you substitute the value from your given above that is being already solved. So you get the value of 0.992. So that was the answer. Pasensya po. Meron na pong ilaw sa amin. Namatay na po. Okay, question number 5. Number 6 rather. Identify the uses of the Poisson distributions. Upon my research, you can use Poisson distributions to predict the likelihood of it happening again. It tells us the chances of certain numbers of occurrences that occurring in a certain amount of time. The Poisson distribution is also used to estimate the rate at which patients arrive at the hospital. So in medical field, it's used to estimate the number of the laboratory, the DNA, the blood tests that being performed based on the number of the incoming patients. Then, 4, it is also used to count the number of suicide in the year. And lastly, it is also used to count the number of the vehicles at the traffic light within the 5 minutes period. So it is very useful, the Poisson distributions. Our last question. The second leading genetic cause of mental retardation is the Fragile X syndrome, named for the fragile appearance of the tip of the X chromosomes in affected individual. 1 in 1,500 males are affected worldwide with no ethnic bias. So therefore, our given here would be, our R here would be 1 divided by 1,500 equals to 0.0067, and your N here would be 10,000. And then after that, you need to get the values from your question, letter A. In the sample of 10,000 males, how many would you expect to have Fragile X syndrome? How many? How how many would you expect to have Fragile X syndrome? From the formula itself, so NP, so you need, so your N would be 10,000, and then you substitute the value of your P, that is 1 over 1/5. 0.00067, the answer of your letter A will be 6.7. So there is a 6.7 that is being expected to have a Fragile X syndrome. And then our letter B question is, for example of 10,000 males, use the Poisson approximation to the binomial distributions to determine the probability that more than 7 of the males have Fragile X syndrome. So therefore, the question is, we need to find the probability of X equals to 7. And then you substitute the value 1 minus by P, X equals to 0, plus P, X equals to 1, then plus P, X equals to 3, and so on, going to x equals to 7 that is being asked, the probability that is being x equals to 7, and then you substitute the value. How to get the p over x of the x equals to 0? So that is p, and then you multiply x 6 minus 7. The 6 minus 7 would be the answers of your question letter A. And then by the permutation of your 0, and then e raised to the 6.7, negative 6.7. And that is also the value of the second, or the another value of your x, would be 6.7 raised to 1, 1 permutations, e raised to negative 6.7. Then so on, going to x equals to 7. And then if you sum it all, so 1 equals to, if you substitute, if you calculate the value of each probability from 0 to 7, you get 0.0012 plus 0.0082 plus 0.0270 plus um, 0.0617 plus 0.1034 plus 0.1385 plus 0.1546 plus 0.1480, and then you subtract it by 1. So therefore the value of your p, that is x equals to 7, it is 0.3568. So that is the answer for your question number 2. And then after that, from the question number 3, for a sample of 10,000 males, use the Poisson approximation to the binomial distribution to determine that at most 10 of the males have fragile X syndromes. So at letter B, it is only asked that is more than 7 of the males. But in this question, the question is at most 10 of the males. So from the same calculations of your letter B, we need to get the X that is being less than or equal to 10. So the probability of your x equals to 0, 1, 2, and so on going to x equals to 10. And then you substitute the value of your x equals to 0 by the Poisson approximations. P, 6.7, that is the answer, that is the male that being affected by the X syndrome. 6.7 raised to 0 with a permutation of 0 multiplied by your E raised to negative 6.7, and then the probability of your 1, P, 6.7 raised to 1, that is 1, and then over 1 permutations, and e raised to negative 6 point um, negative 6.7 over 1 permutations. So if you sum it all, you get the value of this from 0 to 10. You get the value of your x that is less than or equal to 10 would be 0.913. So that is the solutions of the question letter C of number 7. So thank you for listening. God bless us all.